eyedropper in here, a bottle of water. Write down your observations. Wait a minute. Isn't there iron in your blood? I got an idea. Actually, if you look closer here at the eyedropper, you'll see when you squeeze the bottle, the water in the eyedropper actually goes up into it even more. So I'm squeezing the bottle now. I'll show you up here. Squeeze the bottle and you can see the water move up. So when I squeeze the bottle, the water moves up and the eyedropper moves down. See if that changes why you think this happens. Feel free to pause the video and copy these into your notes if you need to, or your handout. So this is my actual explanation. Not squeezing, squeezing the bottle. Notice when you're not squeezing, you don't have very much water in the eyedropper, and when you squeeze the bottle, it fills with water. In the density formula, that actually affects the mass of the eyedropper, but doesn't change the size or the volume of the eyedropper. Remember, density is a relationship between mass and volume. So in the first case, we have a mass slightly less than the volume, which gives us a density of less than 1, and the eyedropper floats. When the top number of a fraction is bigger than the bottom number, you get a density of greater than 1, and the eyedropper sinks. So by squeezing the bottle, we're increasing the mass until it's greater than the volume, and the eyedropper sinks. I gave a math problem here as an example. Let's say the mass is 2 and the volume is 4. We get a density of 0.5 and it floats. By squeezing the bottle, we simply increase the mass. I made up the number 8 here to show that, from 2 to 8, but keep the volume the same. It stays at 4. 8 divided by 4 equals 2, and the eyedropper sinks because it is greater than 1.